Hello students! This is the third online lab and I'm going to be following a set of instructions that I will be posting on Google Classroom. You can easily follow this set of instructions from the video, or you could follow the instructions that are posted in text form. Okay, the first thing that we have to do for this online lab, we're going to need to create our own spreadsheet, and the spreadsheet software that we're going to be using for this is Google Sheets. And we're going to name it according to the naming convention that we are using in Google Classroom. The naming convention is last name, first name, hyphen OL3. So I'm going to go to Google Sheets. I'm going to make a brand new Google Sheet. And instead of untitled spreadsheet, which is a little sloppy, I'm going to name it as last name. In my particular case, Scordian. Let's see, Luke. And OL3. Okay, great. Please don't name yours Scordian Luke, because that's not your name. Okay, the next thing that I'm going to do is I'm going to show you how to do, or show you how to calculate standard deviation using spreadsheet software like Google Sheets. The calculation of standard deviation can be done on this spreadsheet software, and I'm going to walk you through it using some information from a pre-existing spreadsheet. The pre-existing spreadsheet I'm talking about exists in Google Classroom right now. It's called StDev, or Standard Deviation Calculation. So what I'm going to do is I'm going to copy everything from cell A1 to cell E10 and paste it into the online lab spreadsheet. So I'm going to do that now, everything from A1 down to E10. And I'm going to paste it in here. All you have to do is go onto Google Classroom, go to the pre-existing spreadsheet, and click on standard deviation calculation. I'm going to rename this sheet. This sheet is supposed to be named StDev. So StDev, just like that. Great. So we have our spreadsheet already ready. The next thing we have to do is calculate the sample mean, which is X bar. We have to place its value in the box labeled average, which is cell B8. So that's here. If you remember, in order to calculate the sample mean, there are a couple different ways to do it, but there's one easy way to do it using Google Sheets. And that way is using a formula. So the formula starts with putting the equals sign, and sometimes Google Sheets is really smart. So sometimes it'll figure out what you want it to do. In this particular case, it figured out that I want to find the average between cell B2 and cell B6. I'm going to type it out because not every time is Google Sheets going to be so smart. So I'm going to type out average. That's how you calculate the average of some cells. And you could either click and drag, or you could say, open parentheses, I'm going to go all the way from B2 to B6. Why am I not including B1? Why am I starting at B2? Well, B1 is my label, right? This says XI. I don't need to include this in my average because that's not a number, right? That's a label of all the things that are in this range. So press enter and I get the average of 5. How about that? Fantastic. Now in cells C2 through C6, that's from here down to here, the next thing that we're going to do is calculate the difference between the data value and the mean. Keep in mind, this difference between each data value and the mean is known as the deviation. They're deviations from the mean. So in order to figure this out, what I'm going to do is I'm going to say, well, here's another formula, equals, right? B2, so that's X sub I for this particular row, minus the average. Now the average in our particular case was 5. So I'm just going to write down 5. I could write down, B8, but the reason I don't want to do that is this. Once I do the B2 minus 5 here and press enter, I could take this box and simply drag it down like this and get all of the other boxes to have that same information. However, if I were to have B2 minus, let's say, B8 here, right? B8, of course, being the average, that first box would be correct. But if I say I want to apply that same formula to this box down here, it wouldn't calculate it correctly because this says B3 minus B9. Notice B9 doesn't have anything in it. So I have to make sure that the thing that changes, the B2, B3, B4, B5, B6, that's the thing that's going to get changed as I drag it down. But the second value, this last value, can't be B9. It's always got to be the average. It's always got to be 5. So let me undo that real quick. Here, I'm just going to type out the formula again. It's going to be equal to B3 minus 5. And in this case here, it's going to be equals to B4 minus 5. This one's equal to B5 minus 5. And this one is going to be equal to B6 minus 5. Excellent. So we found all of the deviations. Keep in mind, these, the xi minus average, are the deviations from the mean. So that's that third step. The fourth step here is I'm going to calculate in cells D2 through D6. I'm going to be calculating the square of the deviations for each row. There's an easy way to do that using, you guessed it, Google Sheets. Now, in one of the previous examples, when we were trying to find the average, there was a tidy formula called average that found it. In this case, we want to take xi minus average, or the deviation, and square it. There isn't a formula for squaring. However, there's an easy way to get around that. I'm going to put equals to, and you know that to square a value means to multiply that value by itself. So I want to square C2, whatever's in C2. So I'm going to do C2. And then I'm just going to use the asterisk key here. That means multiply. I'm going to multiply by itself. So times C2. Easily done. All right, so that 0 times 0 is obviously equal to 0. I know that negative 4 times negative 4 should be equal to 16. So there should be a 16 here. How do I get that? Well, I'm going to put equals. Then I'm going to put C3 times, you guessed it, itself, C3. And of course, that's 16. I could click and drag down to fill everything in, or I could choose to fill out every formula instead, just to make sure I'm doing it right. Formula. So C4 times C4, and then equals C5 times C5. And sometimes when you're doing this quickly, you might do this. You might make this mistake. This one is supposed to be C6 times C6. So you might type in C6 times C6 and press enter. Notice how it didn't do anything, right? In all of these other cases, we told the spreadsheet software, oh, this equals means I'm going to be calculating something, right? However, in this particular case, I forgot to put my equal sign. So easily solved. I go to the front, I put equals, I press enter. It fixed it for me. Amazing. Nice work, Google Sheets. Okay, now I need the sum of the squared deviations. The sum of the squared deviations is easily found. These are the squared deviations here, 0, 16, 1, 1, and 16. So I could add them together by hand, or I could say, well, I'm going to say go equals to, I'm going to do sum, and then I'm going to put in parentheses from D2 all the way to D6. Not too bad. There's my 34. The next thing that I have to figure out is the variance. It asks us to find the variance. And I've put here that the variance is equal to whatever the sum of the squared deviations is divided by n minus 1. Now, I haven't square rooted it to get the standard deviation yet. Remember, the variance is the standard deviation squared. So I've squared all these numbers. Now I'm going to divide by the number of numbers. Here's my formula. This is going to be equal to the sum of, let's see, D2 to D6. And I have to divide that by, I put parentheses first, then I have to divide that by n minus 1. What is n minus 1 in this particular case? Well, I know that there are 5 values. So I'm going to put in n minus 1, which is equal to 4. Boom. There's my variance, 8.5. So there's finding variance for you. Last but not least, I'm going to find S, which is the sample standard deviation. Keep in mind that all of these are sample values because these are only 5 different values in what ostensibly is going to be a larger set of data. Anyway, the sample standard deviation is calculated by taking the square root of the variance. So you know that the square root of variance, or you may not know that the square root is another formula that is in Google Sheets. Square root is SQRT. So I'm going to get the positive square root of any positive number. In this case, I'm doing the square root of the variance. Remember, the variance is stored in cell D9. So I could put D9 and then close parentheses, press enter. There's my square root. Nice work, Google Sheets. Okay, let's say you wanted to check some of these numbers. Well, it turns out that instead of writing out all of these values or writing out all these tables, you could do this a little bit more easily. Let's try to calculate the variance. I'm going to go out here to cell F2 and write down variance. This is the formula value. In order to calculate the variance, no slash required here. In order to calculate the variance in the formula version, what I'm going to do is put in equals, and then I'm going to use the formula for variance, which in Google Sheets is VAR. And you can see that it pops up the tooltip that says variance. Now I'm going to open parentheses, but the numbers that I'm going to put into this variance formula are the numbers, the individual values, xi. So 5, 1, 4, 6, and 9. So I'm going to put in the variance of all of the values from B2 all the way up to B6. And I would expect that once I press enter, I'm going to get the variance, which is, of course, 8.5. So same number from here, same number from here. I got it via formula, and I got it via using the table. I can also check the standard deviation by using the standard deviation formula. Standard deviation formula. And of course, these are going to be in your spreadsheet as well. That's going to be equal to the formula in Google Sheets is StDev, open parentheses. I'm using the values from B2 all the way up to B6, close parentheses, enter. Look at that. This and this are exactly the same thing. Okay, so you've learned how to use Google Sheets to do sort of a complex calculation, and you've also learned how to use Google Sheets to simplify that calculation if it has the formula for it. Perfecto. All right, step 9 here in the standard deviation procedure is to create a new sheet and title the sheet salaries. So we're going to open up a new sheet here by pressing the plus button, and I want this to say salaries. So salaries, perfect. It also says in this assignment that there are salaries of 13 players on the Cleveland Cavaliers during the 2009-2010 season, which I know by now must seem like ages ago. And those salaries are here. So I'm going to list out those salaries. The first one is $736,000, no comma necessary, and so on and so on and so on. I'm actually not going to do this. You're going to do this by yourself. And then you're going to use Excel to compute the mean and standard deviation of these sample values. I'm not going to do the rest of it because I want to see whether you're able to do it. So again, using these procedures, you can use the formulas to check your work, but I do want you to perform the procedures here as well. On your salary sheet. Okay, moving on to part 2, which is on the 5-number summary. Now you've already opened up the spreadsheet in Google Classroom entitled StDev. Now there's another spreadsheet in Google Classroom called Home and Away. And when you open up that spreadsheet, I will give you a little taste of what it looks like here. When you open up that spreadsheet, you can see that there are different values for the different NBA teams, their wins, losses, and winning percentage for basketball games. And here's the source. Actually, before I pull that away, I will mention that there are many different sports here, 4 different sports here that have similar information. All of these sports have win, loss, and percentage data, like the percentage of wins. For soccer, there's some extra data in terms of points and draws, right? Because that doesn't happen in other sports. It does happen in soccer. All right. It asks you for this part 2 section to copy everything from your selected sports sheet into your Google Sheet under a new sheet entitled with the sports name. I'm going to pick hockey only because I feel like hockey sometimes gets a raw deal. I'm going to copy it. I can either copy it like that or press Control-C or Command-C on a Mac. And then what I'm going to do in my personal sheet, my Scorty and Luke sheet, your sheet is going to be a different name. I'm going to add a new sheet, and its name is going to be the sports name. So I'm going to write hockey. And then I'm going to paste in all the information that I have into that sheet. Next, I'm going to create a new sheet titled Measures of Center. So new sheet. This one is called Measures of Center. And it asks us to copy only the overall percentage for the selected sport into the new sheet. We're going to keep all the labels for that column as well. So I'm going back to hockey, looking for overall percentage, and that looks like it starts here, and it goes down all the way to the bottom sheet here, the bottom of the sheet here, which is row 33. Oh my goodness, what just happened? Let's see. Oh, I'll click and drag all the way down to 33, right? So I started at E3, and I went down to E33. Control-C or Command-C on a Mac, and then on Measures of Center, see how it's blank? I'm going to paste in the percentages of wins here. Great. The next part asks me to calculate the mean, median, and mode for the distribution. Now the formulas are given to you. It says average, median, and mode respectively. And then it asks you to round your answers to one decimal place using the format button. I'm going to show you one example. I'm just going to show you how to find the mode. So I'm going to label this as mode. And the mode is going to be a formula. So I start off with equals, MODE. And the start of the parentheses is going to be A1. Oh, I'm sorry, not A1, A2, right? Because that's where the first piece of data is. So I'm going to go from A2 all the way down to A. Well, if I scroll down here, I'm supposed to go down to A31. So A2 to A31, close parentheses, enter. The mode is 0.524. That's the number that appears the most number of times. You can do that same thing with the average and the median, respectively. I'm not going to walk you through that because it's just 3 different formulas. And you're going to label them here. You can label this one as median, and you're going to label this one as mean. Great. Now, one thing I do have to do to these data is round it to one decimal place. It says to do that using the format button. I'm going to show you how to do that with mode. Under format, I'm going to go to number, and then I'm going to go to number again. It tells me that it wants to structure this as a number, not as a percentage, not as scientific notation, but as a number. So that's what I want. And I also see up here that there are a couple of different possibilities for formatting. This one allows me to format as currency, like 52 cents. I'm going to do Control-Z or undo because I don't want it to be in cents. But this also allows me to decrease the decimal places. It asks me to do, let's see, 1 decimal place. So I want to decrease the decimal places from 2 to 1. How about that, right? So I use the downgrade the decimal place button to reduce it to 1 decimal place. You could round it by hand, but I'm asking you to do the format button, and I need to see that you've changed the format on that cell. Next, it asks you to describe in context the shape, center, and spread of the distribution. That next section, section 5, asks us to describe in context the shape, center, and spread of the distribution. And it's tough to do when you're just looking at data like this, if you're just looking at the so-called raw data in a list form. However, last week you learned about turning data into a data display, and it's much easier to determine the shape if you're looking at a data display. I highlighted all of the pertinent data for my hockey winning percentages, and what I'm going to do is go into insert and then go to chart. There's a bunch of different charts that are here, but I think the best chart to use is going to be the histogram chart, right? There's some other crazy charts here, but the histogram really is able to show us the shape of this distribution. And when I look at this distribution, I see that there is a tail to the left and the concentration is to the right. So I would definitely call this, well, nice try, folks. You're going to have to figure it out for yourselves. If I wanted to describe the shape, center, and spread of this distribution, I would talk about the shape. I would describe the shape as one of the shapes we talked about in class. I could identify the center by identifying either the median or the mean. Of course, since this is how it is, I would probably use one of those measures over the other. I would probably use the resistant measure here over the non-resistant measure. Again, I'm not going to tell you which one that is, but that's just a little hint from me to you. And it also asks us to identify the spread of the distribution. Some measures of spread include standard deviation, IQR, variance, range, that kind of thing. You could use anything. I think probably range would be a pretty good one here to use. You just calculate the range just by subtracting the smallest from the largest. Okay. The next part asks us if there are any outliers. And I don't mind reminding you that outliers are found using a fairly simple formula that you just have to remember, right? Remember the lower outlier fence is equal to the quartile 1 minus 1.5 times the IQR. And then also the upper fence is equal to quartile 3 plus 1.5 times the IQR. You might be saying to yourself, well, how am I going to find this quartile 1? How am I going to find this IQR? Well, guess what? We're in Google Sheets. There's got to be a formula for that. For example, if I wanted to find the quartile 1 is just going to be a formula, which is equal to quartile And I have to identify the set of values, the data values, which is all the way from A2 up until A31. And I also have to identify which quartile I'm looking for. In this case, it's quartile 1, so I put quartile 1. And then if I was looking for quartile 3, it would be a very similar formula to this one, A2 to A31, but instead of writing 1, I would put a 3 there. That would be the formula for down here. Of course, like I said, I'm not going to do everything for you, so those are the numbers necessary to find the lower fence and the upper fence, and then determine whether there are outliers. Amazing. What can you say about the overall performance of the teams that season? I'll let you answer that by yourselves. Next, in section 6, it asks me to create a new sheet and entitle it 5-number summary. So, new sheet, 5-number summary. And the 5-number summary is going to be for the home PCT, the home percentage for your selected sport. So I'm going to go to a different sport because for your particular situation, you're going to be using the same sport the whole time, right? If you pick hockey, you're going to use hockey the whole time. So in order to prevent you from just straight up copying off of me, for my 5-number summary, I'm going to use another sport. I'm going to use, I don't know, how about baseball? And we're looking for, as it says in the document, we are looking for the home PCT. So let's take that home PCT and put it in column A. So the home PCT is in column A. That's these. And I'm going to put them in here. Where is it supposed to be? Here it is. Great. Put it in column A. And then I'm going to put the away PCT, the away percentage for the selected sport, and place it into column D. So that selected sport, of course, is going to be baseball. So let's bring up that baseball again. And let's take that away or road percentage and put it into my spreadsheet for column D. So that goes here. So here's my home percentage and here's my away percentage. Now we're going to calculate the minimum, median, and maximum of the home and place them in cells B1, B3, and B5 respectively. I'm actually not going to show you how to do that, although I will suggest to you that there's a formula for that one. And there's also a formula for the maximum. I'm not going to tell you how to do it, but I'll tell you what to look for. And then you're doing the same exact thing for the away percentages, the minimum, the median, and the maximum, and you're rounding all those to one decimal place using that format button and then decreasing the decimal places. And then for step 8, it asks you to use the percentile formula to find the first quartile and the third quartile. Remember that there is a quartile formula. However, it asks you here to use a formula to find the first and third quartile. So for that first quartile, which is here, I'm going to say, well, percentile. And I'm going to give the range of values, which would be A2 to A31. And now, in order to find the first quartile is the first 25%. So my first quartile is going to be my 25th percentile, right? So that should be my first quartile. Ooh. Sorry, I didn't mean to type 25. I meant to type 0.25. The 25th percentile is going to be the same as the first quartile. I can prove it to you by doing equals quartile from A2 to A31. And if I'm looking for the first quartile, I would put in 1. And it's the same exact number, right? The 25th percentile is the same as the first quartile. Cool. All right, the last question is actually very interesting. I don't want to give you too much information about it. I'll just pose it to you, and then we'll say goodbye for now. It says, based on the 5-number summaries, which is the minimum quartile 1, the median quartile 3, and the maximum, describe any differences you observe between the home and away distributions. So you could observe differences in their centers, differences in their shapes, like one of them might be symmetric, one of them might be skewed, right? Let's say, for example, differences of spread, right? One of them might have a bigger range than the other, and any outliers in the data. Then use the evidence to explain if there's any home advantage in your sport. Now, if there is home advantage, Home advantage means you have a better chance of winning, or you have more wins at home. So you're going to answer the question, is there any home advantage in that sport? You're going to use the evidence that you collected from this to support your argument. You're not going to use your own opinions on that. Okay, and that's pretty much it. So this was the video on OL3, Online Learning Lab 3. And I hope that I described all of the parts of that lab adequately. Again, you're going to be receiving a couple of files on Google Classroom. You're going to receive that standard deviation calculation spreadsheet. You're going to receive the home and away spreadsheet. And you're also going to receive a paper, a document that describes how to follow these rules. So if you didn't like this video, or if you got lost at one part, you can look at the paper document and hopefully it'll give you a little bit more information. All right, folks. Good luck studying.